Hi, this is cylinder jacket of Indian Power Pass 1916. It's a motorcycle, this one. So it's about 110 years old, V-twin 1000cc engine. The owner want to rebuild this engine using the iron cast. So I have to reverse this jacket for 3D printing with the PLA. They will use a lost PLA process for doing the casting. The small green dot that you see is the point cloud from the 3D scanner, the Sermoon X1, and I'm going to use this for reference modeling this cylinder jacket. And the CAD software that I'm using is Autodesk Inventor. Let's do a section view. Okay, this is the flathead engine. It has a valves on the side of the engine. I like the modern engine that has valves on the top. The right here is the intake valve. On the left is the exhaust valve. Exhaust valve is thinner. If you look in this photo, the spark plug is on the intake valve, and this will be the splitter from the carburetor that split the intake to the two cylinders. When I reversed this, I found that back in the day I think they used the clay for modeling this part. Of course, they don't have a computer CAD software like today, so when they model this part, I think they use the clay because I found a lot of asymmetry. I can see that many parts of this jacket is sculpting by hand. They do a pretty good job for people that time. This area is also the combustion chamber. When the spark plug ignite, the area above the valve will be in a compression. The explosion will go into this channel. This kind of engine, it has low efficiency. Let me do the quarter section. Okay, this will give you pictures. Okay, this will be the quarter section of intake valves. So here, when the carburetor inject the fuel with the air, it's going to go into this channel. This orange color is a thread sleeve that used for locking this. So it's not a part of a jacket pushing sleeve. So the air mixture will go here. The valve opened and the spark plug ignite. And it will start to ignite here in this small chamber, and hot air flow into the cylinder in this small gap. So the efficiency of this engine is very low. For 1000cc engine, it's only 16 horsepower. As far as I know, I think it's 16 horsepower. So the efficiency is very low, and it's not water cooled, it's air cooled with the phenolate, and the material is not aluminum, it's steel. And in my previous video, I was thinking that they have a cylinder liner. I think they don't have a cylinder liner. They use a cast iron and then they bore the cylinder directly. So when this jacket worn out, you cannot change the liner. You need to change the whole cylinder, and also the valve seat. When the valve seat is worn out, you need to change the whole jacket. So they make it in just one single piece. Type of engine require less part because the valve locker is in the bottom, is in the crank, so they use less part. Okay, next I'm going to show you step I took to reverse this jacket using the point cloud for the reference, and you will see why that you need to use high precision 3D scanner for scanning this mechanical part that has fitting clearance. Okay, let's get started. First step, I'm going to create a cylinder. This dimension, it was taken when I do the measurement for the bore diameter. I do a separate 3D scan to get this number because this bore diameter is very critical, and I trace the profiles of the point cloud. So the cylinder will end here. This will be the top of the cylinder, and then I use a revolve command to revolve it along this axis. Okay, this is the cylinder head. It's quite difficult to model. they scour it by hand when they make this. So I need to follow that curve, and the only command I can do this is loft command. So I made two sketch. This is the sketch 1 and this is the sketch 2. I space it about 15 millimeter and loft it to the profiles of the point cloud. And this will be the second loft. Same distance, about 15 millimeter, making one more sketch here. Okay, this is difficult. This is the final loft. It's going to end the profiles like this. So I need to use 3D rails, many of them, to control the curve, both outside and especially the inside of the cylinder. This will be the third loft. And then I mirror it using the XY plane. At least the cylinder is symmetry. Next step, I start to create a body of the valve chamber. If you look from the top, they are not symmetry. The exhaust valve is eccentric and intake valve is centric. It's in the center, but exhaust valve for some reason is not in the center, and these two valves is not aligned in the same axis, a little bit off the center. I need to follow them because they have to do it for some reason. I don't know yet, but if you have a high accurate 3D scan, just follow the point cloud. You don't have to think why it's moved 0.5 millimeter to the left, why it's not aligned. Just follow the point cloud. It's the easiest way. If you make dimensional adjustment to this jacket, it's going to affect the other part down to the crank and down to the valve stem. So the best practice is just follow the point cloud. Okay, make a small fillet here. This will be a circular cutout for the valve cover, and then there's going to be a thread in here. Okay, small extrusion. Extrusion for the seat of the valve cover. This will be the extrusion for the valve chamber. So let's come to here. Okay, and then I make a fillet on the connection between the valve chamber and the cylinder. Okay, this will be for the valve seat area. I use the loft command for cutting the air channel from the valve chamber to the cylinder. So this is made by using a loft command. Okay, after loft, you can see that the opening is cut out. I make a small fillet here. I use the intake valve for reference and make a cross-section cut for revolving the valve seat. Red color is cutting the valve seat using the profile from the intake valves. Okay, this will be exhaust valve. Okay, this will be the first fin on the cylinder. Fin is also used for holding the valve chamber, lock it in place. And they make a small step here. I think they do this for reducing the weight. The fin in the back around the cylinder it's about 1 millimeter thinner than the fin in the front, because it has to hold the valve chamber. Inside of the valve chamber, it has ignition, so there's going to be a lot of vibration. So they use thicker fin in the front and thinner for heat exchanging in the back. Okay, next I create a cup shape underneath the valve chamber. I use a revolve command, and inside here is solid, it's not hollow, because I'm going to extrude the intake pipe and then I will hollow it later. Do the same for the exhaust valve. A solid revolve for the cup underneath the valve. Okay, next I create exhaust pipe using a sweep command. This will be the profiles of the pipe, and I use the spline, a 3D spline for the rail. This is a solid, not hollow. Okay, after I sweep the pipe into the cup, I use the revolve command to revolve cut inner wall of the cup. Next I create the inner diameter of the pipe. I make the pipe hollow, so I use the sweep command, but this one is sweep cut. I use the inner diameter from the pipe cloud and sweep cut it. Okay, after that I make a extrusion here because I need to cut the thread adapter, so I need extra wall here. The original design also used this extra wall for increase the thickness of the pipe. it has to be press fitting the thread adapter. This is the intake side. Intake is easier than the exhaust. I snap the plane here on the point cloud because the plane is very important, and extrude it until it reached the cup. As you can see that the original design, the intake pipe is not in the center. It's eccentric for some reason. I am not going to follow this. One side of the wall is thicker than the other side. This one I will follow my instinct that they have made something wrong here. See, it's supposed to be in the center, but it's not, and the wall is already thick. The intake pipe, the wall is thicker than the exhaust. Yeah, it's already thicker than the exhaust. Okay, after that I will cut the intake cup, make a extrusion cut for inner diameter of the pipe, make another cut for thread adapter, and this side also push in thread adapter. Next I create a second fin using the extrude command. I use a fillet command to fillet the joint between the valve chamber and the cylinder. So there's 3 fillets here, last one. So another fillet here. Okay, I make an extrusion here between the cup and the fin for 3mm. This will eliminate a hollow under the cup because this will be the iron casting. You can't have any hollow inside. Make extrusion here. Okay, I use the valve guide for reference and make an extrusion cut for the hole. And then I assign the thread. Okay, and I saw the thread for the valve cover. Then I make an extrusion. It's the opening on the top of the header. And I cut a hole and assign a thread. This cap is for injecting the fuel when the engine cannot start. That's what the owner told me. Okay, make a base of the cylinder mounting point. This is quite thick, 10.5mm in the thickness. Let's start to create a finale on the top of the cylinder. I need to do this in a pair. It's symmetry, left and right. So I need to create only half of this. Each finale it needs different cut because the top of the cylinder, it has a different curve. This one has 20 fins on the top, so it's 18 degrees apart. Okay, this will be the complete model of the cylinder jacket. When I reverse mechanical parts, I also learned from the original designer how much effort that they put into their work. And for this Indian Power Plus engine, craftsmanship of the person who make the mold for this jacket, I think I have seen better. I mean, the machine part is very old. For example, this finale, most of them is not round in the circle, so it doesn't make sense, and some part is eccentric for no reason. Intake pipe eccentric about 1.5 or 2 millimeters. Exhaust and intake valve is not symmetry, even though the diameter of the valve is very close, but it's not symmetry. You can see here the fin is not in the center. I understand they have pen and paper and no CAD software, but the mold maker, I think they should have done better. I've seen a very old motorcycle engine that made in Europe. They made a better quality for the jacket. Maybe this is a low-cost vehicle that they make in the US. Okay, here's a step taken to model this jacket. Modern engine is more difficult to reverse than the older engine. The command I use is extrusion, revolve, sweep, and loft. So I use all the essential command in CAD software to build this model. I use the polar array and the pattern array for copy multiple features. Took me about 4 hours for modeling this part. So it's take quite a long time, especially the finale that has to cut into different profiles on the header. And for the weight of the jacket, it's 5.2 kilograms. So I'm going to reverse. Next part would be either the flywheel or the crank cover. Okay, thanks you guys for watching. I'll see you in the next video.